Today's lesson is about angles, chords, and segments inside a circle. So let's go ahead and get started. The first piece of information we're going to want to look at is how to be able to find this angle measure. So this angle is located on the circle. Its vertex is located at point R. This line here is referred to as a tangent line because it does not intersect the circle. So this line is called a tangent line. A tangent line. This problem, in order to solve it, you're basically using the same mentality you did with inscribed angles. So with inscribed angles, remember, let's see, oh yeah, that's a bad circle. Inscribed is where the vertex is on the circle, and let's say the arc is 100. To get the angle, you divide by 2 to get 50. The same concept applies to this type of angle. So if the full arc that we're looking at is 146, in order to calculate the measure of the angle, you just divide by 2. So 146 divided by 2 is 73 degrees, which is the measure of the angle. So the formula for this one is the angle equals half of the arc, which is just like the inscribed angle theorem, where the angle is inside. So if we were going to apply that to here, there's my arc, here's my angle. So the same mentality works in this kind of problem as well. So if the angle is on the circle, it's half the arc. This next problem involves secants and chords. So notice how we've got two pieces of a circle. It kind of cuts through. A secant, okay, this is just a little bit of review from your notes. A secant is something that intersects the circle at 2 points. So this full line is called a secant. However, if its segment endpoints are located on the circle, it's called a chord. So inside the circle is called a chord, whereas this full segment from here to here is called a secant. So when it goes through the circle, it's called secant. If it stops in the circle, it's called a chord. So that's just some vocabulary that's going to just help us make sure that we're setting our problem up the right way. Let's see here. I'm going to erase just a little. Okay. So notice how we have an angle that's not located on the center. So in this picture, what we end up seeing is two chords. We have a chord located here and here. Notice how those chords cross at two arcs. We have an arc out here, which is 175, and an arc here, which is 55. Those two arcs, to calculate the measure of the angle, you average them. So your formula for if the angle is in the circle but not on the center is angle equals 1/2 x plus y, or basically arc plus arc. It doesn't matter which one x or y is, as long as you're just adding the two arcs that are between. So in this problem, my angle measure is my unknown, so I'm going to put an x here because I don't know what that angle is. Equals 1/2. I'm going to make 175x and 55y. It doesn't matter which one x or y is. All that matters is that you're adding the two arcs together that are between the angles. My x value is isolated and by itself, so I can type this straight into my calculator, but if I don't want to, I'm going to do it piece by piece and then show you how to type it in. So when I add, I get 230. Half of 230 is 115, so that's the measure of your angle. Now you can type this straight into your calculator. Just be mindful that when you do that, you want to make sure that you're typing 1/2 in parentheses and then the 175 plus 55 in parentheses. If you only put the 1/2 in parentheses, like 1/2 times 175 plus 55, your calculator doesn't do the orders of operation correctly. So you need to type it in with the parentheses around your addition. It has to be typed in how you see it because your calculator is only smart enough to do the order of operation. So if you type it in this way, it's going to multiply first and then add versus adding first, then multiplying. Okay. So this one is if the angle is inside but not on the center. Our last one is if the angle is outside of the circle. Now, if the angle is outside of the circle, it is basically the same formula we just did, but instead of adding your arcs, you're going to subtract. So in this kind of problem, it's angle equals half x minus y. But the important part is x has to be the big arc and y has to be the small arc. Big minus small. If you flip it, okay, if you flip it, you get a negative answer, and we don't want negatives. Negatives are no-nos. So for this problem, my angle is still my question mark. I don't know what x is. Equals 1/2. In this problem, my x value is going to be the arc that is furthest away. So I'm going to use 129 as my x. And then I'm going to use 61 as my y. Now it's very important here that you're making sure the big number is first. If you put the little number first, you get a negative answer. Big number first. So x equals half. 129 minus 61 is 68. And half of 68 is 34. Again, you can type this straight into your calculator as long as you are putting everything in parentheses the right way. It is perfectly fine. So let's test it. I'm going to do 1/2 in parentheses, then parenthesis 129 minus 61 for an answer of 34. So it does match up. Be very, very careful though. It's big arc minus small arc. So let's kind of stop and analyze real quick before we do our next set. If the angle is on the circle, it's half the arc. If the angle is inside the circle but not on the center, you add the arcs and multiply by 1/2. If the angle is outside of the circle, you subtract big arc minus small arc and multiply by 1/2. All right, this next section is about the segments. Okay, it's about the segments. All right, so let's go ahead and work on the segment problems. Actually, I think we're going to stop the lesson on just angles and then do a separate video on just the segments to kind of keep it separated. So let's kind of end this here. Remember, angle on the circle, it's half the arc. Angle inside but not on the center, add the arcs, multiply by 1/2. Outside the circle, subtract the arcs and multiply by 1/2. Big arc minus small arc. In the other video, we'll go ahead and do the segment. So we'll finish this practice on the other worksheet. I think that way it'll just be a little bit easier for you.